So we've been talking about the different types of ways to solve. We solve by graphing, we solve by elimination, we solve by substitution, right? So we have three different ways, three different tools in your back pocket that you can use. So for this now, we're going to systems of linear equations and problem solving. If you're given just straight problems, excuse me, it might say solve by elimination, solve by substitution. Okay, when we get to the word problems, it's your choice. Okay, and I'll kind of point out as we go through the different things I look for when I go to decide whether I use elimination or substitution to make life easier on myself. Okay, uh, when we're looking at these, we're going to do, there's essentially four different types of problems that we're going to see that are very common ones. We're going to do some of each type as we go here. And we'll solve some of them substitution, we'll solve some of them elimination. And today there's really no notes, it's just kind of straight problems. All right? That's really the only way you can do this, is just by practice and looking at different things. So, system of linear equations and problem solving. First one we're going to look at is finding unknown numbers. I think these ones should be pretty straightforward. This is what we had back at the beginning of the year. Talked about all those different words, what things mean plus, what things mean multiplication, those types of things. All right, when you start reading it the first time, it's going to sound confusing. First number is 4 less than the second number, 4 times the first number, 6 more than twice the second number, find the numbers. Okay, then you just start breaking it down. First number, so we'll just call x first number and y second number, is 4 less. 4 less would be minus 4, then a second number. All right, there's one equation. See the word is, that's your equal sign. Second sentence, 4 times the first number. So I'm looking at 4 times x is equal sign. 6 more means plus 6, then twice the second. Twice means times 2. So if you start breaking these sentences down into, the different words that are shown, those types of things, it's not horrible then, right? Okay. We identified x as our first number, y as our second number, is 4 less than, 4 times, is 6 more, twice. Those are really the only words you need. So if you take that all into account, you get those two equations. You guys all right with how I got those two equations? Okay. Now looking at that guy, x equals y minus 4, 4x equals 2y plus 6. What are we thinking there, substitution or elimination? I got a pretty strong feeling on this one. What do you think? Substitution. Yes. Why do you say that? Because you have the value already. You have that x already by itself, right? That's what I'm seeing too. Absolutely. You got that x by itself. X equals y minus 4. There's the thing we can take and box up right from the start. Okay? So we take that guy, plug it into the other equation, the one we haven't touched yet. So 4 goes in here. So 4 times y minus 4 equals 2y plus 6. Now what do I have to do? Distribute the 4, giving me? Good. 4y minus 16 equals 2y plus 6. Now what? Spit it out. Okay, you're going to take that 2y across, right? So we subtract a 2y, and then I'm going to add a 16 too. You good with that? I'm going to do it all in one step. So 4 minus 2 is going to be 2y. Over here, 6 and 16 is going to be 22. So y equals 11. There's the first one. Plug it back into the box. X equals 11 minus 4. 11 minus 4 is 7. So then in that situation right there, first number is going to be 7. Second number is going to be 11. Any issues there? I think that one's probably the most straightforward. Okay, we've already kind of done those. Just take what you've known before. You guys know how to take words and turn them into equations. Do the same thing. You just have two of them. All right, so let's get into kind of the newer stuff. So here's the first different type. This one's called a break-even problem. So break-even problem, you're always going to have some type of business typically. And you have your costs to worry about, and you have your amount of money you're bringing in to worry about. Okay, so if you're starting a new business, you need to figure out how much your costs are going to be at the beginning, plus whatever cost it takes to maybe make your product. And then you also need to figure out how much you're going to make. Because obviously, when you start a business, you're going to start in the hole, correct? You have to, the classic, you have to spend money to make money. All right, you're going to be in the hole somewhere. Well, you need to figure out how long it's going to take you to get out of that hole. How long it's going to take you to start turning a profit. Because that's the important thing. Business is all about that profit and profit margin. All right, so in a break-even point or a break-even problem, you need two equations. All right, your first equation, I'd write this down. Break even, your first equation needs to be your expenses. Your second equation needs to be your profit. Okay, those are what your two equations are going to be. First one, expenses all need to be factored into whether you have there's stuff with advertising or startup fees and those types of things, plus whatever it costs to make your product. And then the second one will be profit. How much money are you making? So those are your two equations. And anytime you have a break-even point, you can have y equals something x plus or minus something. Okay, just stick to that form. It's going to make it easier. Where y is going to be the money. All right, these problems are pretty consistent. Anytime you see the word break even or something like that in a problem, you need to start thinking of this example right here. And you'll have one to try here after this. All right, so a fashion designer makes and sells hats. The material for the hats costs $5.50. Hats sell for $12.50 each. The designer spends $1,400 on advertising. How many hats must the designer sell to break even? All right, so in this case, we could do it two different ways. One, we could just figure out how much they make per each hat and so on. Or let's just set it up. Expense one, profit one. This one's pretty simple. I mean, if you look at it and say, all right, I'm making $7 every hat, correct? They won't all be this simple, so let's do it the full way. So first off, let's do one for expenses. So my expenses equation, y equals, how much does it cost me to make each hat? $5.50. Good. So it cost me $5.50 for the material to make each hat, and that would be times x. X is the number of hats. Okay? Is there any other expenses I have? Advertising, correct. Now that doesn't say $1,400 per month or anything, doesn't it? Does it? It just says just a straight $1,400. So maybe I bought a billboard or something like that. Okay, so we'll take that $5.50 times every hat, and let's add on 1,400. So there's my expenses. Now I want to find my profit. How much money am I making? Yeah, how much am I selling for? $12.50. Yeah. So this is one, the way we do these, you don't have to overthink and think to yourself, all right, well, I'm only making $7 a hat. No, we're taking everything into account here. We're selling for $12.50. We're good. So $12.50 X. All right, there's no other money coming in, is there? Just the straight hat sales. All right, so looking at that guy, what are we thinking? Substitution or elimination? I'm thinking substitution as well. Because if you look at that guy, I already got y by itself, don't I? Okay, so I need to put that in the other equation. Y equals 550x plus 1400. That's the one I haven't touched yet. I'm going to put it right there. So I'm going to end up with 1250x equals 550x plus 1400. All right, let's get our x's together. So I'm going to subtract the 550x from both sides. That's going to give me 7x equals 1400. Divide both sides by 7. What's that going to give us? 200. Okay, so x equals 200. Now, we can most likely stop there because it says how many hats, but let's just plug it back in and find the other one as well. I would always suggest finding both variables and then figuring out which one you need for the answer. So what's 1250 times 200? Who's got a calculator? Somebody does. Pull a phone out. Okay. So 2500. So there's my two answers. Y equals 2500, x equals 200. So what does this mean for us? Well, x was our number of hats, correct? Y was our money, right? So this is telling me that it takes 200 hats sold for me to be at 0. So if I sell 175 hats, am I making money? No. Okay, 175 hats, I'm still in the hole. 250 hats, where am I at? I'm making money. All right, and that's what we like. All right, so 200 hats, I'm just going to write that over here. 200 hats is my break-even point, and that's 2,500 bucks is where that occurs at. All right, does that make sense how we did that problem, guys? Okay, and again, I think you could probably do this one. You could skip a step or two and processing, but if you set all your break-even points up like this, you're going to be in good shape.
If they're easy enough to do, like this one, can we do them like that? Just like solve them?
Okay, here's what everything I do with work and stuff. If you got the right answer, you got the right answer. Okay?
Okay.
But if you get it wrong and you did it some crazy way, you're not going to get partial credit. If you get it wrong and did it this way, but maybe you multiply or added wrong, then you're going to get partial credit. Does that make sense?
Yeah, so if I know it's right.
So it's kind of like playing the lottery a little bit. How confident are you in your answer? Obviously, if it's a quiz and it's online, I'm not seeing it work anyhow.
Yeah.
When we do it on paper, that would be the only time you have to worry about that. All right? Now, two, obviously, I'm going to need to see some sort of work with this one.
Yeah.
This isn't one you're probably going to do the whole thing in your head.
Honestly, that's kind of easy.
You can punch some stuff in a calculator.
Even if it's 1400 divided by 7, that's 200.
You could do that. Yeah. And then you plug it back in as well.
Yeah.
If I wanted the price point where it occurred at. All right. Any questions on that one, guys? Feel all right? All right. You guys try this one. This one's a little bit tougher. Same concept, though.
if I get the right, if I get the right answer, I get the right answer. I
Okay.
get the amount of books.
Here we go. Puzzle Expert wrote a new Sudoku book. His initial cost, I should say his, not is. Initial costs are $864. Binding and packaging each book cost 80 cents. Price of the book is $2. How many copies must be sold to break even? All right, so let's go expenses and let's go profit. So expenses, Y equals. So let's just talk. You don't have to give me the equation. What's the expenses he has? $864 is one.
And then the 80 cents a book.
And 80 cents per book, okay? So we want to say X is our number of books. Does that work? All right, then Y would be our money. Okay, so I have to pay 80 cents per book, so that's going to be 0.80x. Now, plus, what's my other expense here? Do I have an additional expense besides the 80 cents per book? I do, don't I?
Oh, yeah, the
864 for the setup fee or whatever it is. 864. Good. All right, now what's my profit equation? Y equals $2. All right, so $2 times X. Now this one here, this looks straight substitution to me all day. All right here, plug it into the other equation. So I'm going to have Y, I'll put this in here. So that's 2x equals 0.80x plus 864. I'm going to subtract the 0.80 from both sides. So now I have 120x equals 864. What's that going to equal? What is it? 720? So x equals 720. All right, there's my first answer. Plug it back in. So y equals 2 times 720, which would be 1440. All right, so how many books did I have to sell to break even? Good. All right, I have to sell 720 books. And my price point, all right, at what price point do I make money? I start making money at 1440. So the first 719 books, I'm in the negative. Starting with book 721, I'm making money.
Maybe he should up his prices.
I agree.
Who bought them?
Yeah, if he has to sell over 700 books to make money, he didn't do so great.
I know it's like $5 a book.
Well, then you always have your whole how many do you plan on selling? If he only plans on selling 1,000, then yeah, you definitely need to up it. If he's planning on selling 10,000, then it's not terrible.
Yeah, I still up it. I should use money.
Yeah. So you just have to. There's a lot of things you have to consider. You have to remember too. The higher you make your price, probably the less you sell.
There's a couple of women that'll be like, "Oh, that's too expensive."
I think definitely a couple guys. I mean, I walk in somewhere, that's too expensive.
I do that, but I still buy it.
All right, next type. I think this one's fairly easy too. This is a coin problem. All right. So anytime you have a coin problem, you're going to have two different items. Now, a coin problem does not just refer to coins. We'll talk about it here a little more in a minute, but there's more that you can apply to this. So a coin problem, your first equation is the number of items or the number of coins. Your second problem is going to be the value of items. Okay, that's how you want to set these up. First one is number of items. Second is the value of the items. All right, so in this problem here, you have a jar full of pennies and quarters with a total of 27 coins. Total value of the coins is $4.35. How many of each type of coins do you have? Well, there's two things I'm looking for. I'm looking for pennies and I'm looking for quarters, correct? So let's just say that X is my pennies and we'll say that Y is my quarters. You all right with that? So first equation, number of items. How many total coins are in the jar? 27. So this is an easy equation. Number of pennies plus number of quarters equals 27. Anytime you have a problem this style, we have number of items and value of items or coins like this, your first equation would be x plus y equals 27. Or x plus y equals the total number. Now, the second thing, we have to take into account the amount of money that we have in that jar. How much money do we have in that jar?
$4.30.
Yeah, $4.35. Okay. Now, let's think back. How much is a penny worth?
1 cent.
1 cent. So that would be 0.01. And we would multiply that times the number of pennies we have. Okay, how much is a quarter worth?
25 cents.
Yeah, 25 cents or 0.25 y. All right. So, first thing I see is I don't like all those decimals. Do you guys? No. All right. If you ever have problems like this, you want to get rid of the decimals. Everything has 2 decimal places. Let's go through and multiply everything by 100 before we even start. If I multiply every term by 100, now I'm looking at 1x plus 25y equals 435. That feels a whole heck of a lot better, doesn't it? All right, easier to work with, all whole numbers now. And now I see something else I like. I see an x here and I see an x up here. See that? X and x. So let's do this one elimination. That be all right? So I'm going to take the first equation here and I'm going to multiply it by -1. That's going to give me negative x minus y equals negative 27. Okay, x's are gone. I have 24y here. And then 435 minus 27 is going to be what? 408? That sound right? Divide both sides by 24. Y equals, I believe it would be 9. All right. So then there's my first one. That's my number of quarters. Plug it back into one of the originals. All right. I'm just going to go back into this guy. X plus 9 equals 27. Subtract the 9. X equals 18. And there's my coin problem. Questions? All right, so why do I say this isn't always coins? One very popular one is where you're going to see something like talking about food a lot. All right, there's going to be, I like food too. I don't disagree. They'll be talking about food a lot and they'll say something like, this, the sandwich cost $4 and a burrito cost $6. And they sold 15 items that day and made this amount of money. How many of each type of food did they sell? Same thing. Number of items, value of items. Number of items, value of items. Does that make sense? All right, so tell you what, let's just do that. I'll make up a problem here for you. That bell's getting ready to ring, isn't it?
Yeah.
All right. All right, so try this guy out. We have, what's it look like? We have Booster Club runs a football stand at home football games. They sell hamburgers for $4 and hot dogs for $1.50. In the first quarter of the game, they sold 31 items and made $94. How many of each did they sell? Okay, so let me just write that too. How many of each did they sell? All right, so you need two equations here. Your first equation needs to be on how much or what the value is. Okay, the value of the item, the total money made. The other one needs to be on the total items sold. So take a few minutes. Boom. All right. The first one, we want to make an equation with the number of items sold. How many did we sell?
31.
We sold 31, correct. So let's just say what hamburgers are X, hot dogs are Y. We good with that? Okay, so the first one, the number sold, X plus Y equals 31. Next one, we have to account for the money. So what's that equation going to be?
We do 4x
Uh-huh.
plus 1.50y, and then 94.
Good. All right. So $4 times the number of burgers, 150 times the number of hot dogs is equal to 94. All right. Substitution elimination. Elimination. You want to multiply the first one by -4? Okay. First one by -4. It's going to be negative 4x minus 4y equals, it's 31 times -4. Negative 124. X is gone. This is going to give me negative 2.5y equals negative what?
31. I mean 30.
Negative 30. Both sides by negative 2.5. That gives me
12.
y equals 12. All right, so that means I have 12 hot dogs. Take that, plug it back into one of the equations. Let's just go with the first one. X plus 12 equals 31. Subtract the 12 from both sides. X is 19. Good. Questions on this one? All right, I think this is another one that's pretty standard. All right, we're down to two more. Two more types. Next one, wind and current problems.
Haven't we already done 3?
We did missing numbers, break even, coin. All right. We got 5 types today.
We do extra.
All right, wind and current problems. So this one is going to apply for any time you have plane flights and boat rides. All right. This one here is just really, really wordy. And a lot of times that's how these ones are. So you need to break them down just a little bit. All right, so a passenger travels from Charlotte to Los Angeles at the same time another passenger travels the same route in reverse. The airspeed of each plane is the same. The ground speed of the west flying plane is 495 miles per hour. The eastern traveling plane has a ground speed of 550 miles per hour. The wind is blowing west to east. What's the wind speed? What's the airspeed of each plane? All right, so here's the big thing we have to think about whenever we are talking about these wind and current problems. So, if I'm in a plane, all right, if I'm in a plane and the wind's blowing in my face, what's happening to my plane? It's getting slowed down. If I'm in a plane and I have the wind blowing from behind, what's happening? It's speeding up. Did I have to change, basically, did I have to change the cruise control on the plane? No. No. If I'm flying 200 miles an hour, okay, I have my plane's cruise control set on 200 mile an hour, and the wind is helping me. Am I going faster than 200?
Yeah.
Yes. If I have the cruise control set at 200 and the wind's pushing in my face, I'm going slower than 200. All right, the difference is our speed is measured in distance, okay? When we're in the air, we cannot track how far exactly we went at all times. Whereas when I'm on the ground, right? When I'm on the ground, my tires, however fast they're rotating going down the road, it measures how far I go, right? When I'm in the air, I don't really have that same assistance. So my airspeed and my ground speed can be two different things. Think of it as airspeed is how fast the plane's cruise control was set. Ground speed is how fast I'm actually going at the end of the day. All right, so anytime you have a wind or speed problem, you're going to have this equation. You have your ground speed equals your airspeed plus or minus wind speed. Okay, so this would be ground. This is air. And this is wind. Okay, whatever that airspeed is, you're going to have to either add or subtract the wind on to find your final speed. You also might find this is the resultant speed. In a current problem, this is going to be your speed in relation to the shore, those types of things. All right, so looking at this thing, he flies from Charlotte to Los Angeles. That's the case. He's flying west. Same time, another passenger travels the same route in reverse. Airspeed of the plane is the same. Ground speed, blah, 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 blah. All right. Wind is blowing west to east. So, usually on this one, you're going to have two equations. You're going to have a to and a from. All right. This problem, we're talking about two different people flying the same one, but a lot of times they will have, it says this guy goes 3 miles downstream and then 3 miles back upstream. Okay. So we'll go to and from. So if he's going from Charlotte to Los Angeles, we don't know the airspeed. We don't know the wind speed. What we do know is the ground speed. When he is going west, he is at 495 miles per hour. When he's going east, he's at 550 miles per hour. Okay, that's my ground speed. That's this one here. So we want to find the speed of the plane, the airspeed, as well as the wind speed. So the plane is flying the same speed both times, so that's going to be my x. X is my airspeed. All right. And then y, we're going to use that as my wind speed. So looking at this, even without paying attention to which way the wind is blowing, which one's west to east, which one has the wind helping and which one has the wind hurting? 495 and 550. The faster one's going to have the wind helping, right? So this one has the wind helping. This one has the wind hurting. Does that make sense? Okay, that's how I figured out the plus and minus. One's faster than the other. Faster one is helping me. All right, now this one's set up perfect for elimination, isn't it? Y's are going straight down. 2x equals it's gonna be 1045. Divide both sides by 2. X is 522 and a half. Okay, so that means the airspeed of my plane is 522 and a half mile an hour. Take that, plug it back into one of the originals. So I'm going to plug it into the second one. So 550 equals x, which is 522 and a half, plus y. I'm going to subtract the 522 and a half from both sides. That's going to leave me with 27 and a half. So this is my that's my wind speed. This is my wind speed. This is my airspeed. Questions on that guy? All right, that one's a little different. A lot of people get tricked up with these ones, but they're really not that tough. Any questions? Try this guy. So you row upstream at a speed of 2 miles per hour. You travel the same distance downstream at a speed of 5 miles per hour. What would be your rowing speed in still water? What is the speed of the current? So this one here, this is be your total speed, which is what's listed, 2 and 5, equals essentially your boat speed, or your rowing speed, same thing, plus or minus your current. All right, this one shouldn't take too long, so give that a shot. So, my two equations. We'll just say to and from. What's my first equation going to be? Anybody?
What are the chances this is gonna be on the test?
2 equals x plus
Good.
y.
You want 2 equals, well, we know we're going to have equal, they're both going to be equal to 5, right? Well, one's equal to 5, one equals to 2.
Oh, what happened now?
Agreed? It doesn't matter. It doesn't matter the order. All right, so which one's going to be plus and which one's going to be minus?
5 is plus.
Good. 5 is the plus one, x is the minus one. Good. All right, and again, it does to and from does not matter. Your x and y answers will still be the same. All right, so straight down elimination. So what am I looking at? 7 equals 2x. Divide both sides by 2. X is 3.5. Plug it back in, so I have 5 equals 3.5 plus y. Subtract the 3.5 from both sides. Y equals 1.5. There's my two answers. What do they mean?
X is and y is.
Say that again.
Is it x and y is?
Yeah, x is air, y is wind. In that course, in this one here, this one would technically be your row speed, which is the same as your airspeed, but if it was in a plane. And current is 1.5. Current and wind speed are similar. All right, last problem of the day. I promise this time. See, it's the last one on my slides. So last one is a mixture problem. These ones are similar to a coin, but all right, they're similar to a coin, but it's going to be percentages. All right, you'll see here in a second. So, chemist is working on a COVID vaccine and needs to mix a 10% sodium iodine solution with a 60% sodium iodine solution to obtain 50 milliliters of 30% sodium iodine solution. How many milliliters of each solution should be mixed? Okay, there's a lot going on here, isn't there? All right, so let's just call this first 10% one, we'll call that one X, and we'll call the 60% one Y. Now, how many milliliters do we want total? 50. Okay, so similar to the coin problem, amount of this one plus amount of this one is the total amount. So we have X plus Y equals 50. Okay, that one's pretty straightforward. If I'm mixing two things together and I want 50 in the end, X plus Y has to equal 50. All right with that one?
Yeah.
All right, so now I have a 10% and a 60%. So 10% times X plus 60% times Y. Here comes the tricky part. We want our last one to be 30%, right? But we need 30% of the 50. Okay, so I have to come off here to the side, and 50 is what I want total. So I need to take 50 times 0.30. So that's going to be the consistency of this 50%. Okay, because right now, I'm going to have a 10% plus a 60% in certain amounts. I want the certain amount to be 50, certain total amount to be 50 at 30%. So 30% of 50 is going to be what? Good, 15.
That took my brain a minute.
All right. Does that make sense? That was kind of the but here. All right. So this is that kind of weird step. All right. So now I'm in pretty good shape. I don't like those decimals again, so let's multiply by 100. Multiply by 100, now I'm looking at 10x plus 60y equals, ooh, I can't write, 100 and, or 1500. 1500. Okay? Now you want elimination substitution. I think elimination looks pretty good here, don't you? Multiply first one by negative 10. All right, so that's going to give me negative 10x minus 10y equals negative 500. X is gone. It's going to give me 50y equals 1,000. Both sides by 50. Y is going to be 20. Still with me? All right, plug it back into an original. So x plus 20 equals 50. Subtract the 20 from both sides. X equals 30. Boom. So I need 30 milliliters of the 10%. And I would need 20 milliliters of the 60% to give me 50 milliliters of the 30%. Does that make sense, guys? All right.